Hello everyone, my name is Ahmet Sözen and today I'm gonna talking about quadcopter landing on a moving target using machine vision. What is the aim of my project? First of all, the precise aerial movement of quadcopter landing on a moving target using machine vision are a spectacular demonstration of technical complexity in the field of highly specialized aerial skills. This sophisticated method giving giving highest level of accuracy and control with smooth integration of machine learning algorithms for two aerial vehicles, for example, quadcopters, mm, non-humorless vehicles. Duty of my project. My project has two main parts. The first part is image processing with machine learning. The second part is autonomous flight control. What is my goal of my project? My drone in the air can recognize or can understand where is the target and landing clearly on it. And using from the landing using machine learning and aided image processing. Image processing need in my project because if you are not using this image processing, my drone can't understand how to land it in a target. Otherwise, autonomous driving can be achieved. I work on two different systems were tried image processing. These systems are CNN system and YOLO V8 system. The first system is CNN Convolutional Neural Network System. Neural network system, this deep learning approach aids in the differentiation of different things or objects in the image from one another one. Um, I I have a low data. I have I had low data for project. K-fold cross-validation helped to me data augmentation problems. I had training and test folds or sets, and these, for example, five-fold cross-validations. It's five divided equal parts of my datas, and after that, it's multiply and increase my datas. Why was the CNN system developed? My data sets very tiny, very low, was low. I first set up train and test sets using k-fold cross-validation methods. For my best models, for my best pictures, I optimized hyperparameters and divided the data with five-fold cross-validations. I produced it. After that, the data sets were divided, and then I used data augmentation, a lot of data. I enlarged the train set by 8 times with just this. I then complete the training following the hyperparameters adjustment. The parameters were trained one last time. Firstly, I trained my sets and training sets with low data, and it was very bad. After using k-fold cross-validation methods and horizontal rotation and vertical rotation Gaussian blurring methods. I increase my data with for data augmentation. After that, I trained trained my last data after that methods. My success rate of almost 0.96 you will see in this graphics. I training from 10 epochs cycle times and training and validation accuracy and you will see training and validation accuracy and training and validation loss. These graphics shows us what can I understand is this graphics. CNN uh, after the datas, many datas, it will be worked clearly and can learn the models can learn. And this CNN system is so fast from the YOLO V8. But methods of classification and color histogram are valuable. The most curious aspect is not whether the object exists. Uh, Classification and color system are valuable, but can understand these target exists or not. But can understand where is the target. I can understand the location of target. But YOLO V8, when I was trained because of YOLO V8 was trained because of insufficient stability in the position, despite the fact that searches are conducted based on the intensity of red color, if any, on the screen and placement is done appropriately. I choose a red color because it's a main color in the color sites. My targets it's a red circle. So I try to train the red color. These algorithms can work in red the picture. Firstly, read the picture. After that, make classification with CNN system. After that, if the result is target, after the classification is the target, you can step 4, but is not, you can go back. After that, if this target, if you see the target for after the classification, convert the HCV color space to understand red color. Select the places highlighted in the red and show them in the picture. After that, if these can understand the target, like this. YOLO V8, this is my second system for image processing. YOLO V8 is one of the newest state-of-the-art products that can be used to object detection, image classification, and instance segmentation task. Data augmentation, like a k-fold cross-validation methods, it's need to be use this equations to data augmentation. For the 5 separate train and validation sets create and data augmentation was applied of the all of the train tests and the number of data was increased 8 times with the applied methods. After these methods, rotate image vertically, rotate image horizontally, and k-fold cross-validation methods, my data increased 8 times. So I did use these methods. So why was the YOLO 8 system developed? YOLO V8 created this dataset before training with five-fold cross-validation. The data was increased 8 times again. So why was YOLO 8 used? The reason for this is that YOLO V8 can know the accuracy of the object with successful percentage. Uh, Successful percentage better than the CNN, I know. Precision, recall, and map values are perfect. So they are far ahead of the classification and also provide the bounding box itself. YOLO V8 can draw your own bounding box itself, but CNN system cannot draw it. So the position of the object can be obtained almost perfectly. So YOLO V8 can understand object's location and what is the object perfectly, more perfectly from the CNN system. For epoch 100, precision recall and map 50 values are that there are results. You will see these graphics from the YOLO V8 results. Train and validation sets decreases epoch to epoch. So what will show us that graphic? It means our training is going training successful, and the model learned well, can memorize the picture, and because of validation loses decreases. Validation loses decreases show us models learn well and can memorize. They are not memorized pictures. So comparisons, differences of CNN and YOLO V8 in our models, which we developed using accuracy CNN, it's 0.5095. However, in YOLO V8, precision is 0.99 and recall value is 1. When compared to our CNN model, the YOLO model's accuracy value is extremely high. Yeah, YOLO's accuracy value more than extremely high, higher than CNN. But so YOLO V8 better than CNN. Even if our CNN model is quicker. CNN faster training faster than YOLO V8, but YOLO V8 not so slowly. It's only a little faster than YOLO V8. At the same time, we said that there would be a variety of errors in the CNN cooperation we produce with color. CNN cooperation has a many color errors about it, but YOLO V8 it's very good for colors and boundaries and the others. Only slower than a little bit CNN. Thanks for watching. Thanks for listening. Have a good day for everyone.